Hey all, so as you might have guessed, just like there's a multiplication principle, there are also addition and subtraction principles. So we're going to look at those today and talk about how those can be a helpful way to solve some of these more complicated counting questions. So the first ones we're going to start out with just give us a little bit of space and a little bit of review of the multiplication principle. So get yourself ready for notes and we're going to get started. So these first two don't have very challenging parameters, so we're just going to use the multiplication principle. First one, number one, how many even 5-digit numbers are there? So we're going to treat each of the 5 digits as an event. And when we make even numbers, we're only looking at the last digit. So the last digit can be 0, 2, 4, 6, or 8, but the other digits can be whatever you want. Because 78 is an even number because the last digit is even. So we have 5 options for this. The middle digits can be anything that we want. And then the first one can be anything but 0. So, because if it's 0, then it's a 4-digit number, not a 5-digit number. So for the first digit, we only have 9 possible outcomes. And this is just a nice straightforward multiplication problem. We get 45,000 as the answer. Now, how many are there with no digit 0? So we're going to do similar things. 1, 2, 3, 4, 5. The first ones never could have the digit 0 to begin with, so that's going to still have 9 outcomes. Now the next ones are also going to have 9 because they can't have a digit 0. So there's 9 possibilities. And for the last digit, it can't have the 0. So we have 1, 2, 3, 4 possible outcomes there. So then our final answer, we could type this in as 9 to the 4th times 4, which is 26,244. Now here's where we're going to maybe want to start using some of our other principles. So 3 asks, how many 5-digit numbers are there with no 0, and the digit 6 only appears once? So we're going to use this, and we're going to use the addition principle for this one. And what the addition principle states is that we can separate the outcomes into non-overlapping subsets. So in this case, the ones I am going to consider are going to be where 6 is in the first spot, the second, the third, the fourth, and the fifth. And this is just going to make it a lot easier to think about these critically because these outcomes aren't quite the same. So if it's in the first spot, the first digit has 1 outcome. It has to be a 6. The next can't be 0 and it can't be 6. Those are the 2 parameters on the next digit. So that has 8 outcomes left for the next 3 digits. And then the last one can't be 0, it can't be 6, and it has to be even. So there's only 3 options for that last digit. Now, if 6 is in the second place, we leave that here. And then again, the first can't be 0, and it can't be 6. So again, 8, 8, 8, and 3. So the next ones will follow the pattern pretty closely as what we've laid out. And this is why it's really important, though, to think about them separately, is this final one does not have it. The last one is got to be 6, and then the others are all 8. So now to find our total outcomes, we take the sum of those subsets. So we're going to type that into a calculator and add them all together. To make life a little bit easier, we will note that the first 4 subsets have the same outcome. So this would just be 4 times, I would type this in as 8 to the 3rd times 3, plus this last one, which is 8 to the 4th, giving us our total number of outcomes as 10,240. Now, The addition principle is great, but sometimes there are going to be so many of these separate little subgroups that you're actually going to want to maybe consider using the subtraction principle, such as we see in number 4. So number 4 says how many length 4, so 4 elements, can be made with the letters A, B, C, D, E, F, and G, if it has to have at least one E, and repetitions allowed. So what we would do here is we could do the subset where E is first, E is second, E is third, E is fourth, where there's 2 E's, where there's 3. There'd be so many different subsets that it would take a really long time. So in this case, I'm going to use the subtraction principle. I'm going to find its complement and find the universal number, the universal set, and subtract them to find this set. So in this case, number 4, the complement of at least one E is no E. So how many lists of length 4 are there that don't have any E's in them? Well, we have 7 letters here, A through G. So all we're doing is taking away one of those possibilities. So this would be 6 for each part of the list, meaning that there are 1,296 possible lists that have no E in them. Now, to find the universal, this is just all length 4 lists of this set. And as I said, there are 7 letters here. So we've got 7 times 7 times 7 times 7, which would be 2,401 total. And so then to find the ones with at least one E, all we need to do is say, well, I'm going to take the total, which is 2,401, and I'm going to take away all of the ones that don't have any E in them, leaving behind 1,105 that contain at least one E. If you have any questions on the addition and subtraction principles, be sure to set up a Zoom or ask me in the comments and nominate any homework questions that you have in the form attached here. I'll talk to you later.